VA resin is stored in a highly alkaline solution of sodium hydroxide, caustic. Personal protective equipment must be worn when handling chemicals. Refer to the relevant SDS requirement. Applicable warning signage is required to be displayed during use. Correct disposal of the alkaline waste generated is essential. It must not enter freshwater streams or stormwater drains. Ensure you understand the work instruction before starting any operations. If instructions are unclear, contact VAF Memstar and ask your supervisor. The operator must operate the equipment using the VAF Memstar's manufacturer's recommendations and procedures. Any alterations to equipment require prior approval from VAF Memstar. The work order will specify the capacity and number of required VA resin columns. Locate the column in a suitable area, close to the associated reverse osmosis nanofiltration equipment with access to suitable waste drainage and freshwater supply. Note: all water used in conjunction with VA resins must be chlorine-free, requiring carbon filtration prior to use. First step is to remove the free-flowing caustic solution from the resin column. To do that, connect permeate hose to the bottom outlet of the column and the other hose end to suitable waste drain. Note: forward direction is when liquid enters via the top of the column and exits the bottom valve. Open bottom valve, draining caustic to waste. Observe liquid flow. To speed drainage, if required, apply nitrogen gas pressure at less than 200 kilopascals to the N2 port. Once flow from the column stops, turn off nitrogen supply and shut all column valves. Whilst the column is draining, connect water hose to supply and the dosatron. Refer to Appendix 1 for dosatron operation. Next, backfill the column with water to remove air from inside the column and the resin bed. Connect permeate hose from the dosatron outlet to the bottom valve of the column. Connect another permeate hose from the top valve of the column to the waste drain. Open the top and bottom valves on the column. Turn on water supply to the column via the dosatron and set flow to 4 to 6 bed volumes per hour. Flow rate is visible via the attached rotameter. Once water flows from the top valve hose, let it run for 15 minutes and then turn off water and shut column valves. Next, forward flush all remaining free-flowing caustic from the resin bed in preparation to receive permeate. This is an important step, requiring close attention. In order to do this, connect the dosatron outlet to the top valve of the column. Connect another permeate hose from the bottom valve of the column to the waste drain. Open the top and bottom column valves. Turn on water supply to the column through the dosatron and set flow to around 3,000 litres per hour, visible via the dosatron's rotameter. Initially, the waste stream will be highly alkaline. Using the pH and EC meters, monitor the drop in both pH and EC whilst rinsing with water. It is important to measure and record the pH and EC of the tap water being used to rinse the column. See Appendix 2, Use of pH and conductivity meters. The target EC is 1.5 times the value of the tap water used to rinse the columns. For example, if tap water EC is 400 microsiemens, the target in the rinse water leaving the column is 600 microsiemens. pH of the water leaving the column will be in the range of 11.5 to 10.8. The critical measure in the flush water is conductivity, EC, with pH important in supporting the conductivity result. If you have any concerns with column readiness, consult your supervisor and VAF Memstar. Once the conductivity result is achieved, turn off water supply and close column valves, leaving the column full of water. The column is now ready to treat permeate. To start the VA reduction process and introduce permeate into the column, first connect a permeate hose from the permeate outlet of the reverse osmosis nanofiltration machine to the top valve of the VA column. Next, connect the column bottom valve to an inline carbon filter, returning the filtered permeate to the wine, directly via the reverse osmosis nanofiltration machine. Open the VA column top and bottom valves and start permeate generation. Taste for permeate at the column bottom valve. The desirable permeate flow rate into the column is less than 5 bed volumes per hour. The VA reduction process is now occurring. During the VA reduction process, acetic-rich permeate enters the VA column and leaves the column having negligible acetic acid. Periodically monitor and record the pH and EC of the permeate leaving the VA column. The pH value of the treated permeate leaving the VA column will trend down from approximately 11 pH, with the EC remaining relatively constant. Once permeate pH reaches 6.5, the column is exhausted. No further acetic acid will be removed. At pH 6.5, stop the process and swap to a freshly rinsed column or regenerate the exhausted column. Close the column inlet valve and leave the column outlet valve open. Once the column is exhausted, it needs to be drained of permeate. This can be done using either nitrogen or water. The preference is to use nitrogen to reduce dilution risk. If using nitrogen, attach a nitrogen snap lock fitting to the N2 fitting on the column top inlet. Apply a nitrogen pressure of less than 200 kilopascals. This will push permeate from the column back into the parent wine. This can take some time depending on the N2 flow rate and size of the column. Once nitrogen gas is evident through the permeate rotameter, pipework, and bottom valve, close the nitrogen feed and slowly open the top valve to release pressure. Close both the column and wine return bottom valve and remove the permeate hose. The exhausted column is now empty of permeate and ready for regeneration. The next step is to backfill the column with water to remove nitrogen from inside the column and the resin bed. It is preferable to use warm water at 40 to 45 degrees Celsius throughout the regeneration process to achieve a deeper clean. Connect permeate hose from the dosatron outlet to the bottom valve of the column. Connect another permeate hose from the top valve of the column to the waste drain. Open the top and bottom valves on the column. Turn on water supply to the column via the dosatron and set flow rate to 4 to 6 bed volumes per hour, visible via the attached rotameter. Once water flows from the hose connected to the top valve, continue to rinse the column for 2 bed volumes to remove traces of permeate and to loosen the resin bed. Note: the next step involves the use of high-strength sodium hydroxide solution. This and the waste generated are highly alkaline and pose a risk of severe chemical burns. Ensure correct PPE is worn. With a hose connected to the top valve and directed into a waste drain, commence dosing 50% concentration of sodium hydroxide liquid, caustic, via the dosatron into the column's bottom valve. Refer to Appendix 1, Operation of a dosatron. Ensure water flow is equal to or less than 2 bed volumes per hour. Once dosing starts, measure pH and EC of the liquid coming from the column out of the top valve. Note this value. Also note the color of this waste liquid now as it changes over time. Continue to dose caustic and frequently measure both pH and EC. Also note the color of the waste stream. Once pH is 12.5 to 12.8 and EC is more than 20 millisiemens, and once the waste stream color is light brown, stop dosing caustic. Remove the dosing hose from the liquid caustic. Carefully water rinse it and place it in a bucket of water. Recommence dosing to draw water through the dosatron, rinsing caustic from the mechanism. Turn off water and shut the column valves. Remove the connecting permeate hoses from the column, noting they contain a caustic solution. For added safety, add approximately 100 grams of dissolved citric acid to the bucket and recommence dosing, drawing the weak acid solution through the dosatron and through both permeate hoses to neutralize the caustic. Once the column is regenerated, it can be drained and rinsed for immediate use or left on caustic for storage. Note: if warm water is used, please leave the column's top valve open to prevent vacuum damage as the column cools.